Okay, here's the blanks filled up here at the top. We've got these 6 shapes, which there's also, it could just be a parallelogram if it doesn't follow any of these. I think all of these examples follow, or did I say quadrilateral? I don't know. Yeah, but these are how you prove. You have to have all of these things proven in order to say, oh, it's a rhombus or a kite. Like, you have to have 4 congruent sides for it to be a rhombus and no right angles. For rectangle, 4 right angles, but then it also has to, like, follow all of the parallelogram properties, which, if it has 4 right angles, it will follow those parallelogram properties. All right, so we are just going to go through this. It says use distance formula. Again, I don't really like to use distance formula for this. I would prefer to use Pythagorean theorem, so that's what I'm going to choose to do. But it says to find the distance. So remember, when you're creating these, I might just use a different color. It's a little bit easier. These right triangles, you're going to start at one point and you're going to go, you could either go down and over. I'm going to go outside the shape because it looks less crazy. And it goes over 2 and down 3. And I had a good question yesterday asking, like, do they need to be negative? When we're talking about slope, yeah, it would be a -3. But in this case, since we're talking about distance, you can never have a negative distance. So it's not negative, 3 units long. And that's what we're talking about here. But I should probably I started with BC for some reason. Oh, well, we'll just go for it. 2 squared plus 3 squared equals c squared. 2 squared is 4, 3 squared is 9, so it becomes the square root of 13, which is about 3.6. So remember, you can just leave it at square root of 13 if you'd like, or you can change it to 3.6. It's up to you. But things that I want you guys to notice is, like, as you go through this, if you already have a triangle that's 2 and 3, and you get to another one, it's like, oh, it's also 2 and 3, it's going to be the same. Like, it is also going to be the square root of 13 if you have the same numbers putting into the same formula, okay? 2 squared plus 3 squared, 13. So the square root of that is your answer. So you've got 3.6 there, and then you look and, like, literally all of them are the same. 3 and 2. Okay, so yes, we've got the square root of 13, or 3.6 for every single one of these, which is nice, because you don't have to do it over and over again. You can just count the sides, and then you're done. All right, and then another thing I like about Pythagorean theorem is you already have, like, the rise over the run drawn. So for AB, it's, okay, and then things that I saw yesterday, make sure you're just, like, rise over run. So it's the vertical change over the horizontal change. Some people were looking at this and say, oh, it's 3 over 2. But that's not how it is. It's the it's the vertical change over horizontal. So it's 2 over 3 because it goes up 2 over 3. And then also, if you put Bob on that line and he walks to the right, he is going up. So this is a positive slope. So make sure you pay attention. 2 of these are going to be negative. 2 are positive. CB is negative. So I'm going to put that there. And then AD or DA is negative. So that's going to be negative. Okay, so going to BC, it goes down 3 over 2. So hopefully you guys are noticing that there are some perpendicular slopes here. This is 2/3. This is a different sign and it's flipped. So we actually have 4 right angles here. And I'm going to show you how this needs to be written. You've got your 4 right angles because these slopes are perpendicular. And then you also have 4 congruent sides. So if we look back up here, we're like, okay, oh, you know what, for square, oh, this was missing last year and I never added it. We need to add this. And for congruent sides. 4 right angles and 4 congruent sides. That's important. Needs that. And, all right, so it is a square. I cannot write. I forgot the A. There we go. It's a square. And why is it a square? The because part was something that was missed a lot on the test last year. And it's because people were not putting all the information that was needed. So why? Because for congruent sides, and then you need to show that. So like, this is how it's shown. AB is congruent to BC, which is congruent to CD, which is congruent to AD. So remember, these these are interchangeable. You can write BA instead of AB, but it's basically these four sides are congruent. Technically, you should have the little thing on the top. I would not count off. Even if you just put equal signs in between all of them, I wouldn't count off. Either, it's just, I want you to show that all four sides are congruent. Like, you gotta write it out there. And then there are four right angles. All right, and then how do we write that? That's a little bit more complicated on how you write it, because you have to write, there's got to be four perpendicular signs to mark each of these being perpendicular. So AB is perpendicular to BC. AB perpendicular to BC. That's this right angle is what that shows. And then we move over BC and CD. BC is perpendicular to CD. That shows this right angle. So you see the two lines that I'm talking about, and that shows your second right angle. All right, and then CD is perpendicular to DA, or AD, whatever you want to say. CD is perpendicular to DA. And then DA is perpendicular to AB. So like, if you wrote this out and you accidentally wrote AB is perpendicular to DC, that's wrong, because those are parallel. So you can't just pick whichever one you want to write. It has to be two of them that intersect at a right angle. Okay, half the battle of this is graphing it correctly. Because if you don't graph it correctly, that's a lot of things that are going to be wrong. Okay? And also makes it really difficult to grade. So make sure you graph it correctly. This one's nice because it's 1, 2, 3, 4, 5. Two of them you can just count. So like AB is 5, DC is also 5. So that's nice. And for their slopes, pretty easy too. Just make sure you remember, this is something that I saw a lot last year, is like, if it's a horizontal slope, it's going to be a 0 slope. If it's vertical, it's going to be undefined. Don't mix those up. Remember, if you put Bob on that line and he walks to the right, he's not going to fall off because it's a 0 slope. He just doesn't go up or down. So AB and CD, they both have a slope of 0. All right, and then we can solve, which this looks like there's going to be 4 congruent sides on this one as well, because this is a 3, 4, 5 Pythagorean triple. 3 squared plus 4 squared. So see, I just made my right triangle. I counted the sides. 3 squared plus 4 squared equals c squared. 9 plus 16 is 25. Square root of 25 is 5. So in this case, you would not be able to leave it as square root of 25 because it can be simplified to a whole number. All right, you need to go ahead and, if it's perfect square, simplify it to a whole number. And then AD, it's the same thing. It's 3, and this is 4. So 3 squared plus 4 squared equals c squared. C equals 5. We got 4 congruent sides again. Look at that. All right, both of these are positive slopes. So they go up 4 and over 3. 4/3 is the slope. And we've got 4 congruent sides. So 4 congruent sides. We can write that. AB is congruent to BC, which is congruent to CD, which is congruent to AD. And then for here, there's no perpendicular sides, but we do have opposite sides. And we didn't write anything like this yesterday. No, we didn't, because we didn't have parallel sides. So this is new. This is like the last new thing. Opposite sides are parallel. And how do I know that? Because you are looking for slopes that are the same. So this is how you write parallel. So AB is parallel to BC. And then, that's wrong. What am I doing? I'm going to just change the B to a D. And then CB and BC are the same thing. And AD are parallel. Okay, so what is this? And, you know, this is kind of tricky because technically for a rhombus, the only information you need, you really only have to have this. I am just showing you this because on a parallelogram, you will have to have that, and I don't have that example in here. But you're probably like, well, then why do you write it down? It's just to show you how to write that two sides are parallel. Why is this the only thing that you need? Well, if you look over here, this kind of is a cheat sheet of telling you what you need. For this, you just need to write that there's 4 congruent sides. For a square, we needed to write that there's 4 right angles and 4 congruent sides. For a parallelogram, if something is a parallelogram, you would need to show that the opposite sides are parallel and the opposite sides are congruent. So it just depends on what shape it is. But since in the example I didn't have that, I wanted to just show you that. On a rectangle, you just have to have 4 right angles. And here's the reason. The reason for that is because if you show what's on there, it proves that it is a rectangle. If you have 4 right angles, then the opposite sides are going to be parallel and congruent. It just has to be that way. If you have 4 congruent sides and then there's no right angles proven, well, then it has to be a rhombus. Okay, because if the 4 sides are congruent, the way that the shape works, it's going to have to be that. So that was sort of complicated, but this is a rhombus. So if you want to, if it helps for you to understand, like, this is the only thing you have to have when you're showing, like, that it is a rhombus. So, like, on the test, that's what I'm going to be looking for. I'm going to be looking for what is listed here. This is what needs to be proven, okay? The reason I showed you this is to show you how to write the opposite sides are parallel, and you will need to write that if that's a parallelogram, okay?